Hello everyone, I am Dr. Archana Kushwaha, working as an assistant professor in Institute of Aeronautical Engineering. Today I am going to deliver a third lecture based on the engineering material, and that is rubber, their types and their applications. So in this lecture we will be able to understand what is the meaning of rubber and what are their types, what is the compounding and vulcanization of rubber and their properties and application. Apart from that, we will understand what is the meaning of that synthetic rubber and their examples based on synthetic rubber. So in this lecture, we will cover that a few contents, that is a natural rubbers, preparation of a natural rubbers and application of a rubber. What are the defects which is having that a natural rubber? What is the compounding and vulcanization of a rubber? What are the properties and application advantages and disadvantages of vulcanized rubber? Apart from that, we will discuss about that what is the meaning of a synthetic rubber and their few examples, that is a styrene rubber and butyl rubber and their properties and application. Now coming to the natural rubber. Before going to start the meaning of natural rubber, first we should know what is the meaning of a rubber. Rubber is any material which should be a polymer, and apart from that polymer nature, it should have contain that elasticity property. And the elasticity of a rubber is due to its coiled helix structure. We will discuss later also what is the meaning of coiled helix structure and by which how it is going to be having that elasticity properties. Now coming to the natural rubber. Natural rubber, that means it will form by the nature. Nature means something which is already they are there in the nature. So natural rubber is a high molecular weight hydrocarbon polymer represented by the formula C5H8, and C5H8, it is nothing but it is a monomer of a natural rubber and we will call it as isoprene. And it is obtained from the milk emulsion which is called as a latex, and this latex is formed by the tapping of the bark of the tree of Hevea brasiliensis, and this is the tree which is found especially on the tropical places, for example Amazon forest. Even in India it is found at Kerala as well. Now coming to that composition, the main composition of a natural rubber is polyisoprene. Polyisoprene, it is a polymer which is formed by the monomer isoprene, that is nothing but C5H8, which is in the form of long coil chain. Because of a long coil chain, it is having the property of elasticity. The isoprene unit polymerized to form the rubber, and isoprene is a natural rubber exists in two geometrical isomers. Isomer, that is a cis and trans. We will discuss the structure later. And especially the cis polyisoprene, it is natural rubber, while that trans polyisoprene is present in gutta percha rubber. This is the another type of rubber. If I would say about what is the structure of an isoprene and what are the structure of a polyisoprene, we will see the reaction. Here isoprene means there is a two double bond, and here whenever it will break, it will form here double bond, and this will again what we are calling as, I have already discussed these things. What is the meaning of functionalities? Means where any of the other material or other molecule bind which this position, we will call as functionalities, or we call as the vacant place where any other molecule can bind. So here this is the position, it is vacant now. Now here only it is going to start that another monomer, and by addition of that all the monomer, a polymer will form, and that polymer is nothing but polyisoprene, which is called as rubber. Now we will look at this picture. This is the cis polyisoprene and this is trans. This is the geometrical isomer. Geometrical isomer is having a two type of isomer, that is a cis and trans, and it is based on what are the priority we are giving in the structure, especially for the molecule. On the basis of that molecular structure or that priority for that molecule which is present in that particular molecule, we are calling this structure will be a cis polyisoprene or a trans polyisoprene. If we will look at this, if I would say about a priority, look at this carbon. This carbon is having two type of molecule, that is one of this molecule and another is this. If I would compare in these two, it will be a second priority while this should be a first priority. Why first priority? Because of bulkier molecule. Whenever we are talking about priority, we are talking about what is the bulkiness or what are the molecular weight of that particular position molecule, and on the basis of molecule we are giving the priority. So here we are giving one priority and here we have given second priority. And now coming to this carbon position, if we will look at this is also a first priority and this will be a second priority on the basis of their molecular weight. So whenever any of the carbon-carbon double bond having this type of structure, means it will be a first priority here, and here also it is a first and there it is a second priority. Whenever all the smaller molecule on the one side and heavier molecule on other side, then that isomer will be a cis, while vice versa, like whenever double bond is there and this is first priority, this is first priority, this is second priority and this is second. So whenever it will be in opposite direction, then we will call this trans isomer. Now coming to their another structure. Okay, first of all, any of the rubber which is formed by the monomer, that is a isoprene, it should have some condition, that is it should be having a heat, pressure as well as catalyst. Catalyst is mandatory since we are preparing any of the polymerization, that catalyst is mandatory. So in the presence of heat, pressure and catalyst, we have formed four types of molecule. Here I am just dealing with cis 1,4 position and trans 1,4. Now coming to the position as well, if we will look at this, I am just talking about this isoprene. Here that one priority, this is 2, this is numbering I am talking about, 2, this is 3 and this is 4. So if we will look at this, double bond will form in between 2 position and 3 position, and this is 1 position, this is 4 position, 1, 2 and 3, 4. Here I am, if we will look at this structure, one, 2, 3 and 4. Now whenever that polymer will form, first this bond and this bond will break, and here just because of vacancy, that double bond will generate like here. If I would say about any of the homolysis fission, then it will be a so here one free radical, here one free radical, this is another, and this. Whenever 2 free radical will form on the adjacent carbon, it will form double bond with this electron. So again it will be here 1 and here 1. That's what I am talking about, 1 and 2. This position is vacant where any other molecule will bind together and form a polymer. So if we will look at this position as I have given here, 1, 2, 3 and 4. So on the basis of this, what are the number 1 and 4 we are talking about if we are considering 1 and 2 carbon, that is cis position and trans position. On the basis of this, we are talking about this is a cis position, cis 1,4 position, and this is trans 1,4 position. If we will look at here, this is priority 1, this is priority, and this is second priority. This on this carbon, and this carbon number is second, and this is third carbon number. Here, if I will look at this is a one hydrogen. Here, that this is second priority, and this one is first priority. So it is cis 1,4. Why 1,4? Because this carbon is first carbon, and this carbon is fourth carbon. So it is a cis 1,4 isoprene, polyisoprene molecule. And if we will look at this molecular diagram here, this isoprene, cis isoprene, as I have said, cis isoprene only, cis polyisoprene only form that a natural rubber. If we were looking this structure, this cis isoprene, polyisoprene molecule bind together and form a like this type of helix structure. So on the basis of this helical structure, it is having, whenever we are bind one position with any of the place, and we are stretching this rubber, then it is showing that elasticity nature. Elasticity means whenever we are leaving that particular force, it will reshape in the original shape. This property is nothing but elasticity property. See, on the basis of this helical structure, it is having that elastic nature. Now coming to the preparation of a natural rubber. So for the preparation, I said we have to form with that tree, and it is formed by that liquid that is nothing but latex. So latex is the rubber milk containing about 30% to 45% rubber, and the rubber milk is diluted with water and allowed to stand for some time. The clear liquid form, the top is treated with the acetic acid and a formic acid. This is very important. We have to treat with the acetic acid and a formic acid to coagulate the rubber. Coagulate is nothing but we are accumulating that particular molecule and coagulation will happen. So the coagulated rubber is thoroughly washed with the water and then passed through a roller to get sheets of the rubber. And rubber sheets are finally dried either in air. Here, if that air will be there or in smoke will be there, then we will call, and maintaining the temperature 40 to 50 degrees centigrade for a 4 days, then the rubber will called as a smoked rubber. While during the coagulation of a rubber milk with acetic or formic acid, retardants means which decrease the rate of that formation of rubber. Retardant we are using like a sodium bisulfate, NaHSO3, are added to prevent the oxidation of a rubber. This is called the crepe rubber. Thus, natural rubber is obtained from the latex, which is formed by the tree Hevea braziliensis. Now coming to the application of a rubber, the major application of a natural rubber is in the manufacture of tires and in heavy duty tires. Heavy duty tires means at which we can load heavy things. That tire is suitable here, and the major portion of that rubber is used in natural rubber. The tank lining in the chemical. This is the very important use of rubber tank lining in chemical plants where corrosive chemicals. Corrosive, again the meaning means it is never react with the air, or little bit it will affect by the air, but it is having a non-corrosive nature, where that corrosive chemical are stored, are prepared from the rubber. Foam rubber is used for making cushions, mattresses, padding tires, and sports item are manufactured from the natural rubbers. Gutta percha is used for making submarine cables, golf balls, covers, tissues or adhesive, etc. Now we have to discuss about what is the meaning of a synthetic rubber. Before that, we should know what are the defects it was there in the natural rubber. Just because of some defects only, we are forming that synthetic rubber. So here are some listed defects are there, that it becomes soft and sticky during summer, and it becomes hard and brittle during winter. It swells up in the oil, and it flows plasticity due to the prolonged stress, and it is easily affected by the chemicals. Now coming to the compounding of rubber. As we have learned about what are the defects in the natural rubber and what is the natural rubber. So to strengthen the natural rubber, we are adding some additives, which is nothing but compounding of rubber. So natural rubber is compounded with certain substances to increase the quality of rubber. For example, reinforcing agents or hardness. These are compounded with the natural rubber to give strength to the rubber. For example, carbon powder, zinc oxide, calcium carbonate, etc. Now coming to the next compounding of rubber, that is a softener. These are the added to make the rubber more soft and elastic. As we know that rubber means it should have as much as possible elasticity nature. So that's what we are adding softener. For example, vegetable oil, stearic acids, paraffin oil, etc. Now the next is antioxidant. These are added to prevent destruction of a rubber due to the aerial oxidation. Aerial oxidation means it will react with the air. That's what we are talking about, aerial oxidation. So to prevent this type of aerial oxidation, we are using antioxidant. And if we are adding antioxidant, it will show more and more non-corrosive properties. And these are beta-naphthenol, phenol, etc. Now coming to the volcanization, this is very important property or additives which we are adding in the compounding of rubber. We will discuss in detail later also, but first we should know what is the meaning of volcanization. Volcanization is a process of heating the natural rubber in the presence of a sulfur at 140 degrees centigrade in carbon dioxide atmosphere. So by volcanization, the hardness of the rubber is improved. And for this purpose, what we are adding? We are adding sulfur. Now next is pigments, that is a coloring material. These are the added to give a different color to rubber. For example, metallic oxide like zinc oxide for a white color, lead chromate for a yellow color, chromic oxide for a green color, and the carbon black for the black color. Now coming to the accelerator, that is, these are the added to speed up the volcanization reaction of rubber, and these accelerator are benzothiazole. So we have to process that volcanization should be fast, then we have to add accelerator like a benzothiazole. Now coming to the last, that is a fillers. Fillers are added to increase the quantity without affecting the quality. So for increase the quantity, with what we are adding? Fillers. So the production cost is reduced. Why? If the product will be more and more, so it will be a profitable manner. For example, for this purpose, what we are adding? Textile waste, asbestos, mica, gypsum, tar, etc. Now coming to the details of a volcanization of a rubber. As we know what is the meaning of volcanization. We have to add a sulfur in the presence of sulfur at 140 degrees centigrade in the presence of carbon dioxide atmosphere. Now coming to the some history behind that volcanization. The raw or a crude rubber is a little useful because it has a very undesirable properties such as low tensile strength, and it possesses a elasticity only over a limited range of temperature. So to improve the properties of a rubber, Mr. Charles Good, it is first time invented volcanization of rubber in 1939 to compound the raw rubber with the chemicals and heat. Now coming to the what is the meaning of a vulcanization again. In order to give more strength and more elasticity, natural rubber is heated with sulfur and sulfur compound at 100 to 140 degrees centigrade for a few hours in the presence of carbon dioxide atmosphere. And right now coming to the what will happen in the natural rubber while vulcanization of the rubber. Since here we are adding sulfur, so other layers of that natural rubber, it will bind with the sulfur atom or sulfur, by which some cross linking will be happen throughout the structure, and just because of cross linking, the strength of the rubber will increase. Now coming to the statement, the sulfur combined chemically at the double bond. Here double bond is we have to know, like in the isoprene, what we are, this is the isoprene. Whenever it will form that rubber, it will like that. This is the transform. So gutta parcha, if we would say about cis form, then it will be like that. So many of the layer of this polyisoprene layer, that sulfur bonding will be there, and by the bonding if of this sulfur, and it will bound with here only, because what we are calling about at the double bond position. See, the sulfur combines chemically at the double bonds of a different rubber spring and provides cross-linking between the chains. Between the chains means if this is the one layer and this is the second layer of that rubber, cross-linking will be like this or this. Maybe sometimes two sulfur will be there, or sometimes one sulfur. It depends on what are the molecule we are taking. Now here, so all the layer of natural rubber bind together via the cross-linking with the sulfur atom, and this cross-linking during vulcanization bring about the stiffening of the rubber by anchoring and consequently preventing intermolecular movement of a rubber spring. This process is known as vulcanization of rubber. So if we will look at this picture, these all are the single layer of rubber, natural rubber. Whenever means vulcanized rubber, if I would say about, this is the one layer of a helical structure of a cis 1,4 polyisoprene. This is the second layer. And then in the presence of sulfur, this bond cross-linking between this two layer of a natural rubber, that cross-linking bonding will be there. On the basis of this bonding, that is strength of this rubber will increase, and we will call it as vulcanized rubber. So if we will look at this picture, this is the sulfur atom or sulfur molecule, and by which that cross-linking happen, and the strength of this vulcanized rubber will get increased. So in summary, vulcanization is a process of heating the natural rubber with sulfur at 140 degrees centigrade in the presence of a carbon dioxide atmosphere, which enhance the property of rubber, for example, tensile strength, elasticity, and resistance to swelling and hardness. To swelling in the sense, when we are keeping in the oil at a rubber, that it will never swell. So this is the advantage of vulcanized rubber. And the hardness of a rubber increase as the percentage of sulfur increase, and 2 to 4% sulfur addition gives soft elastic rubber. When sulfur content is more than 30%, hard rubber, which is called as ebonite, is obtained. Now look at this picture, molecular structure. This is the raw rubber of a polyisoprene. This is the one layer and this is the second layer. In between this sulfur, in the presence of a sulfur, that sulfur cross-linking will happen, and this is nothing but vulcanization of rubber. So after vulcanization of rubber, what will happen? The strength of this rubber will increase, the tensile strength will increase, and many more. Natural occurring, if we will look at this picture, we will get to know what is the meaning again that a natural rubber, then vulcanized rubber, and what are the advantages. High strain induced crystallization will happen. Now coming to the properties of a vulcanized rubber. So vulcanized rubber has a very little electrical and a thermal conductivity. Very little electrical and thermal conductivity. That means it is behave like an insulator, and we will use it at many places where electricity will generate or any kind of electricity will generate. We are using rubber to protect any kind of a danger. So hence it is mainly used for electrical insulation purposes. Vulcanization makes rubber much stronger, more flexible, and more resistance to heat and other environmental conditions. Other environmental condition means we can protect by air also. That's what we are talking about, non-corrosive nature of that vulcanized rubber. And vulcanized rubber makes both soft and hard type of objects, ranging from a rubber bands to the boiling balls. And it has high tensile strength, and also having a load bearing capacity means whenever we are using any kind of truck and we are loading a lot of the things, so rubber should be, or our tire should be that much strengthened. It will never damaged while loading any kind of material. So that's what we are talking about, load bearing capacity. Now coming to the next property, that is a corrosive chemicals, as I have said earlier also, and oil do not affect it. It is also not affected by the atmosphere, and vulcanized rubber has a excellent resilience. Resilience, again, it is the meaning elasticity. That means it is having a more flexibility and elasticity nature. It has a better resistance to the moisture, oxidation, and abrasion. It is a resistance to organic solvent, for example, carbon tetrachloride, benzene, petrol, etc. When we are using, it is having a lot resistance towards this kind of organic solvents. Now coming to the next, that is again, it is having a high elasticity property. Now coming to the application advantages and disadvantages of vulcanized rubber. So application, that means vulcanized rubber has a many kind of application. For example, vulcanized rubber is used to make rubber hoses, shoe sole. What are the shoes we are wearing? For the sole we are using vulcanized rubber. Tires, as I've said, good quality of tires, especially for a load bearing capacity. Bowling balls, bouncing balls, hockey punches, toys, eraser, and instrument mouthpieces, etc. Most rubber products in the world are vulcanized, whether the rubber is a natural or a synthetic. Synthetic means we are using monomer, or we are different kind of monomer, and which we are preparing in the laboratory or anywhere else. But natural means it will form by the nature, like latex, and then again we are doing many process to strengthen the property of latex or rubber. Now coming to the advantages of rubber. Advantages of vulcanized rubber, that vulcanized rubber is stronger than a non-vulcanized rubber. Why? Because it is having a cross-linking between the each layer. That's what we are calling as a high strength type of rubber is vulcanized rubber, because its bond are made, as I have said, cross links at an atomic level. This allows a vulcanized rubber to stand up to more strain and damage. Vulcanized rubber is also more rigid and non-vulcanized rubber. Than non-vulcanized rubber. Rigid means it will having a more tensile strength. So it is more stretch strength. Resistance means whenever we are living with the position, means while pulling we have given some external force. When we are we are removing that particular force, it will again go back to the original position. That's what we are calling as stretch resistance in the first place. However, vulcanized rubber has the some elastic level as non has the same elasticity level as the non vulcanized rubber, because whether natural rubber or a vulcanized rubber, both are having elasticity property, and that's because of elasticity nature we are calling as rubber. So rubber terminology is there just because of their elasticity nature. So whether it will be a natural or a vulcanized rubber or we call as a synthetic rubber, it should have some elasticity property. Now coming to the disadvantages, since in general there is a no disadvantages, but somewhat it is having some hazardous property as well. When we are burning this kind of vulcanized rubber, it will be harmful for the health. So coming to the synthetic rubber or rubber itself, it is a meaning, it should be a elastomer. Elastomer, I have said about in my previous lecture, that when we are classify that polymer, it is based on 4 classification was there, which I was already discussed in the second lecture. In this, whenever we are classified on the basis of a intermolecular forces, that one of the classification was elastomer. So elastomer, it is nothing but a natural rubber as well, or we call it as a rubber. So those polymer in which the intermolecular force of attraction between the polymer chain are weakest. This is important. Whenever it will be weak, we call as elastomer, and have an elastic character like that of rubber, and are called as elastomer. So elastomer means having the elastic property, and as well as here intermolecular forces will be a weak forces will be there. So because of the impending weak forces, polymers can be easily strained by applying a small stress and regain their dominant shape when the stress is deflected. The most important example of an elastomer is natural rubber. So these polymers consist of a randomly coiled molecular chains. As I have said, if we will look at this coil type structure, that cis 1,4 polyisoprene, it is having this type of helical structure, and just because of this coiled helical structure, it is having a good property of that elasticity, and that's what we are calling as rubber. So natural rubber is an elastomer made from the latex, a milky tree sap. Synthetic elastomer are made from the petroleum. So rubber is frequently used to indicate elastomer that must be vulcanized and cured to be useful. So all the terminology I have already discussed previously. So a synthetic rubber is any artificial elastomer, and they are polymer synthesized by the petroleum byproducts. If we will look at this picture, this is the natural rubber which is formed by the latex, which is obtained from the tree, and this is the synthetic rubber, and that synthetic rubber is made by the polymerization of a petroleum based product. Now coming to some example of synthetic itself, it should be formed by the synthetically, especially by the petroleum products. So coming to the example of a synthetic rubber, that is a styrene rubber. A styrene rubber we will call as a Buna S rubber as well, and or SBR and GRS. First we should understand what is the meaning of a Buna S. Buna means it is formed by the Bu and A. Okay, Bu means butadiene, whilst Na means it is again a sodium, symbol of a sodium, and S stands for styrene. Now coming to the GRS, And SBR means styrene butadiene rubber. GRS means government rubber styrene. So it is approved by the government, or we can call as government controlled rubber styrene. Now coming to the definition of styrene rubber, it is a copolymer of a butadiene, and in which butadiene we are taking 75% and styrene that should be 24%. It is prepared by the copolymerization. Copolymerization, again I have already discussed in the previous lecture. Copolymerization means we are taking different type of monomer. For example, if we are taking one butadiene that we are calling as A, and styrene that we are calling as B. So these both different type of monomer when we are taking, then then polymerization process we are calling as copolymerization. Copolymerization of butadiene and styrene in the presence of sodium catalyst. So Na is nothing but a sodium catalyst. So in the presence of a sodium heat, and we are going for the polymerization, these type of molecule will form, and we are calling as Buna S. So if we will see here again, when this bond and this bond will break, again here double bond will form. So this is the double bond of this, and this here, as we know that this both carbon is now having the functionalities. So on the basis of their bonding property, this is again it will connect to this. So if I am giving 1 in numbering, 2, 3 and 4. So on the basis of bonding, we are calling as, here if I am saying here, this is 1,3-butadiene. Now again that bonding is in between 2, 3. And this 4 carbon, it is attaching to the carbon of styrene. So this 1, 2, 3 and 4. This 4 is again connecting with the carbon of styrene. This is the molecule of styrene, and this is the 1,3-butadiene part. So on the basis of this one copolymerization of a 1,3-butadiene and styrene, that formation of Buna S will form. Now coming to the properties and their application. So properties of a Buna S are like, it is having a strong and tough polymer. The rubber can be vulcanized similar to the natural rubber. Vulcanization, again it is a one part of the compounding. That means we are adding that sulfur in the presence of a temperature and atmosphere, like a carbon dioxide atmosphere. Natural rubber using either sulfur or a sulfur monochloride, and it is having a good electrical insulator. It possesses excellent abrasion resistance. It is a resistance or to chemical, but swells in oil. Here this is the some drawback also. It swells in oil and attacked by even a traces of ozone present in the atmosphere. It possesses a high load bearing capacity and resilience. So that's what we are making tire by using this type of rubber. Now coming to the application part. So major application of styrene rubber is manufacturing of tires, as I have said, because it is having a load bearing capacity. It is used in a footwearing industry for making shoe soles and footwear components. It is also used for making wires, cables and insulators. It is also used for the production of a float files, tank lining in chemical industries, and many more properties are there, applications are there. Now coming to the next example, that is a butyl rubber, we call as a GRI, that is a government rubber isobutene. So butyl rubber, it is a nothing but it is formed by the copolymerization of a isobutene. In that isobutene, how much we are taking, that 98% we are taking isobutene with butadiene 2% or isoprene 2% in the presence of anhydrous aluminum chloride. So if we will look at this picture, this is the isobutylene and this is isoprene in the presence of cationic polymerization, by the process of polymerization, butyl rubber will form. If we will look at this, here again, one carbon is there which we can bind, and here double bond will form. And this again, it will attack to, means bind with this two, and like this butyl rubber will form. Now coming to the properties and application of a butyl rubber, that properties are the rubber shows extremely low permeability to air and other gases, and it also possesses resistance to heat, mineral acids, polar solvents, etc. It can be vulcanized with sulfur, but it possesses low hardness due to less number of double bond. It is containing a less number of double bond. That's what after vulcanization also it will possess a low hardness. If we will look at this picture, here is the only one double bond. While in other type of polymer, that bonding will be double bonding will be more. Whenever bonding will be more after vulcanization, cross-linking will be more, because cross-linking position is double bond in between, means by the double bond of one layer of a rubber to the another layer of rubber. Now coming to the application. So if we would say about the application part, butyl rubber is used for making cycle and automobile tubes, and it is also used to making hoses, conveyor belts, insulating cables, tank lining, etc. So in the today's discussion, today's lecture, what we have discussed, that is natural rubber, preparation of a natural rubber, application and defects of rubbers, compounding and vulcanization of rubbers, what are the properties, advantages, disadvantages and application of a vulcanized rubber, synthetic rubber and their example, that is a styrene rubber and a butyl rubber. So hope you will understand all these discussion which we have done today. So for that, I hope you will understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.